Yes, our lesson continues. Vectors and scalars. Lesson number 7. I gave a new number for the lesson. Probably we are a little behind according to the original plan. So I just named it lesson 7. Here, difference of two vectors. I'll be talking for some time, but in the middle, if you have any problem, you can just express it immediately. Subtracting a vector b from a vector a means adding a reversed vector to b, reversed b to a. That is, keep writing please. So I'll be changing the screen. That is, vector a minus vector b equals vector a plus minus of b. It looks logically a simple thing. Like you might say 3 minus 2 is 3 plus minus 2. But there is more to it. Logically, it's all right. Like a minus b, adding a negative b to a. Okay, let me show it geometrically also. I'll later talk about the physical significance of it. I have two vectors like this. Say this is vector b somewhere there. Now, when I wanted a plus b, either I followed the law of triangular vectors or the law of parallelogram of vectors, geometrically speaking. So what do I do for a plus b? I'll put a like this, bring b this way by parallel transport. Then I will say this is my a bar plus b bar, vector a plus vector b. And same thing as you do from the law of parallelogram of vectors, you will do this. You will have a and b written twice, once here, once there. Our vector a plus vector b.
Sir, the above one should be a vector A.
Yeah, this is vector a. I'm sorry. This is b. All right. So Either this is triangle law of vectors. This is parallelogram, right? That's all there, but deliberately I showed it back. But now what do you do for a minus b? Look, I'll be doing it on the left side. I have a as it is. Now I will reverse b like this. This is my reverse b. To follow the tail to tip method, I'll just parallel transport it like this. This is my minus b. Now tail of a to tip of a to tail of reverse b. This order we followed. So this will be my vector a minus vector b. Isn't it? Adding a to minus b. The original vector is like this only, you know, but I reversed and added. But if I do it by law of parallelogram vectors, it will be like this. This is my a, right? This will be my, just like that. So I'll just move it a little. Space is not enough. I have to form a parallelogram with a and reverse b. A will be here. Reverse b will be here. Isn't it so? The original b is like this on the right. Check it. So reverse will be like this, and I move it like this. So this is once again my a. This is once again my reverse b. This will be the diagonal. So this is my a minus b. This is like this. This is like this. So hope you followed the geometry there. All right. So it's reversing and adding means you're actually getting a new vector again, not a plus b. Okay, it's neither negative of a plus b. It is something different. Look, in terms of the parallelogram, if you say this diagonal is the main diagonal, people call it. This is a plus b. The other diagonal is this is the other diagonal, right? So the other diagonal is a minus b. So any questions, children? I can show you other examples. Can I move to the next slide?
Yes, sir.
This is a minus.
Yes, sir.
This is a minus b here. This one. What I was trying to tell you was, in this diagonal is a plus b, but this diagonal is a minus b. Same thing, isn't it? You move it parallel. This was the original direction b, right? Okay. So if I move this diagonal there, this will become the other diagonal. Isn't it so? Hello. This is a. This is b. The original vector is like this only. Try to understand. So this is my a plus b. This will be my a minus b. This is our A minus B. You know how? I already told you. It is the reversed B. Tip to tail, so tail to tip. There itself we can show it. If this was B, this is minus B. So tip of minus B to tail of A if I go. So this will be tail of minus B. Tail of minus B to tip of A will be resultant. So this diagonal is A plus B, this diagonal is A minus B. Any questions further? Later, without stopping, I'll go for the cosine rule. The cosine rule will go. Look, A, the original B is like this only, but the parallelogram I'll form if I reverse it like this. This is minus B. Can you hear me? Hello, children.
Yes, sir.
Yeah, the power has gone. That's why I was asking. Now, this is our A minus B. The magnitude of which I would like to find out. That now I'll draw no extension here. Here only I can draw normal, like we did while finding out A plus B. This normal. This angle was theta, children. All right. This is it. So if this angle is theta, can this be angle be theta? Huh? Hello?
Yes.
Tell me. This angle is theta. Will this be theta? I was asking.
Yes, sir.
That only I put, right? Huh? So this length will be how much? Because this is minus B. So cos theta equals x by this hypotenuse mod B. So x equals mod B cos theta. Similarly, sin theta in the figure equals sin theta would be, this is y by mod B, opposite by hypotenuse. You should not write minus B here. This is only the magnitude. So y equals mod B sin theta. Now, when I want this square, the hypotenuse square in this triangle, right angle triangle, which I am showing there, this is the right angle triangle. In this right angle triangle, apply Pythagoras theorem. If you do that, mod of this whole square equals this length square. This length is total mod A minus x whole square plus this one y square. But this would be mod A minus x is mod B cos theta whole square plus y square is mod B sin theta whole square. If I don't write anything, it is mod only. So if I simplify it, I'm just writing one step. I mean, skipping a step here to save the space. Mod A square plus mod B square minus 2 mod A mod B cos theta. This is for mod of A minus B whole square. Therefore, mod of A minus B would be under root mod A square plus mod B square minus 2 mod A mod B cos theta. This is for the magnitude of difference of two vectors. And similarly, if I want the angle made by the A minus B with original A, if I call it alpha, for the direction, I'll get a similar formula. That is y tan alpha equals y by mod A minus x, this length, which is mod B sin theta divided by mod A minus mod B cos theta. This is for tan alpha. This is for the magnitude, that's for direction. And you may notice in the formula for the sum, if you substitute 180 minus theta in the place of theta, you get these formulas. If theta is the angle between A and B, 180 minus theta is the angle between A and minus B. So without deriving like this, I could have gone even directly to that formula. What was the original formula for mod of A plus B? Mod of A plus B would be root over mod A square plus mod B square plus 2 mod A mod B cos theta. Now, theta is the angle between A and B, but when I am subtracting, I am reversing and adding. So this angle will be 180 minus theta. So if I substitute there, I'll get mod A square plus mod B square plus 2 mod A mod B cos 180 minus theta under root. Cos 180 minus it is minus cos theta children. This is for A minus, this is not A plus B. Here I am writing A plus minus B mod. So A minus B mod equals, it becomes A square plus B square minus 2 mod A mod B cos theta. Just by substituting in the place of theta, 180 minus theta, you get it. Similarly, the direction formula for sum was this: tan alpha equals mod B sin theta. Now I'll write sine of 180 minus theta by mod A plus mod B cos 180 minus theta. Sin 180 minus theta is sin theta only. This is mod A minus mod B cos theta, because cos 180 minus theta is minus cos theta. So tan alpha formula for difference of two vectors. That alpha will be below. Previously that alpha was above A. It is below A. So angle made by the difference of two vectors. The new vector which you got by subtracting B from A, that makes an angle alpha given by this formula below A. So this is purely from geometry, but since we have told already that sum is nothing but adding the negative one, I use the sum formula and put in the place of theta 180 minus theta and got the same formula which we derived from the geometry here. So quite elaborate. I was not asking you something because it is already discussed for some, so it should not be difficult to follow with a small change.
Sir, like if they ask what is the angle between the negative B and A minus B, what should we do, sir?
Negative B and
Vector A minus B.
This one.
Yes, sir.
Tell me.
Sir.
You know theta, you know alpha. So you can subtract from the total 180, right? Alpha you've got. Alpha plus theta, you know.
Yes, 180 minus alpha. Yeah.
That's all, isn't it? So your questions are welcome. So subtraction is reversing and adding. Now, what are your thoughts on this? What are your thoughts on this? Tell me.
Sir, then like how to find the angle between vector B and A plus B?
Tell me.
B vector and A plus B.
Hmm.
It will be in that way, na, sir.
Theta minus this. What is that? Theta minus alpha. Because anyway, theta was there. So once you have alpha, theta minus alpha will be that angle.
So now
Tell me.
in the sum, in the if we get numbers, how to know which angles is for what? Like they will not mention
The
the
formula
distance
we are writing is with A. That you should remember.
with A.
Yeah. The formula we are writing with A. If you want to put A there, anywhere you can put. That's not the idea at all. Like if you are drawing the, if I say this here, this is B, then B will come in our formula. Instead of A sin theta by mod B minus mod A cos theta. So
Yeah.
the figure should tell you as to what you're doing, right? The figure is right there in front of you, okay?
Yes, sir.
That's why the geometrical picture is very important. Tell me, children. Others? Manasa? So much mass is done?
Yes, sir, I understood.
Gayatri?
Understood, sir.
Okay, now I'll ask a question. Is subtraction of vectors is same as addition of vectors? Yes. Shivacharan, are you there?
Yes, sir.
Is there a difference between the two, or are they just one and same?
They're similar, I think.
Similar means like I want a little more. I would like to see who will answer this question. An open-ended question. Even in subtraction, we're adding. So are they different or same?
Like we in addition we'll add the same vectors, but we in subtraction will add the negative of one of the vectors.
So the two vectors are different.
Yes, sir. Yes, sir.
The vector A plus B is different from vector
A minus B.
A minus B.
Sir.
This is a pure logical way of talking. But still, we should know that A plus B is different from A minus B. Okay. Any further questions? Vignesh? Okay, let me finish off the discussion. After that, we'll come back. Shall I continue then?
Yes, sir.
I'll continue. Now, cases, special cases. 1 when theta is 0. What do you mean by that? The two vectors are in the same direction or parallel. Now, mod of a minus b would be under root mod a square plus mod b square. Tell me, minus 2 mod a mod b cos 0, 1. So is it mod a minus mod b whole square under root? So is it mod a minus mod b, isn't it? Or mod b minus mod a? So when theta is 0, compare it with sum. Hello. Compare it with sum of two vectors. That is, mod of a plus b was becoming mod a plus mod b. I don't know whether you understood the logic. So here, this is the minimum value of sum, minimum value of the difference. We'll put this in brackets. Okay. And if you look at geometrically, vector A is like this, vector B was like that. So A plus B would be a longer vector like this, but A minus B would be, I'll put A as it is and reverse this B. So after reversing, you add, you get in this direction a smaller A minus B. If you look at it geometrically. For example, if this was 10 Newton's force, if this is also 10 Newton's force, this will be 20 Newtons. Sorry, if this is 20, if this is 10, this will be 30. Now, in this case, what will happen? If this is 20 Newtons, if this is 10 Newton, this is 10 Newtons. Do you agree?
Yes, sir.
Do you agree, Vishnuvardhan?
Yes, sir.
If it were me, I wouldn't agree. This is okay, but this is meaningless. Do you follow? What it means is, if I have a block like this, if I have two forces acting, one is 20 Newtons and the other is 10 Newtons, the net force on the block is 30 Newtons, I'll say. But if I subtract the forces, it is not net force or anything. It is not meaningful. So here I won't add, I won't subtract forces, believe me. Probably their velocities, for example. Velocity of one particle and another particle, then that gives a physical meaning. Do you follow my point? So physics of adding vectors, physics of subtracting vectors is different. Mathematically, of course, that's all. Okay. Tell me, Vishnuvardhan, do you follow?
I didn't understand, sir.
Huh?
I didn't got it, sir. Get it, sir. Bye.
On a block, if you apply two forces like that, there's no physical meaning in subtracting forces.
Yes, sir.
Supposing you subtracted, you got 10 Newton force like this. You got a 10 Newton force like this. What is the meaning of it? The net force is 10 Newtons.
No, sir. If one of the force is applying in opposite direction, it gives 10 newtons of force.
So that is sum, isn't it? So this will be meaningless. That's what I was told.
Yes.
But, because there's a subtraction in mathematics, you cannot subtract forces on a given body. Do you follow?
Yes, sir.
You only add. That's the reason I told you physics examples of sum of two vectors is adding forces. So you don't once again subtract forces for some reason to find the net force.
Yes, sir.
Anybody else? So can I continue? So for this, I cannot give the example of forces. I should give some other example, which I'll be giving anyway. Hello, children.
Yes.
So I'm moving ahead.
1 minute.
Yeah. So now tell me. Everything, what all I am writing here is to be understood properly. It's a combination of logic and physics. That's where actually the challenge. It's pure logic people follow sometimes. Pure physics without math people follow. But the culture that physics must be expressed in mathematical terms is actually the big leap one needs to make in their learning method.
Answer.
So can I continue?
Wait a minute.
Okay.
Done, sir.
Okay. Now case 2. When theta equals 180. That means vectors are in opposite direction originally. This angle is 180. So you'll know that mod of a minus b would be, what will you get? Mod a square plus mod b square minus 2 mod a mod b cos 180. So cos 180 is minus 1. So minus becomes plus here. Plus 2 mod a mod b under root, which is mod a plus mod b. Compare it with sum. Compare it with a plus b. That was what? Mod a minus mod b. And this is the maximum value of difference. This is the maximum value of mod of A minus B. Geometrically speaking, what will I get? If A is like this and B was like that, after reversing, it will become like this. That's why mod of A minus B would be mod A plus mod B. That means the vector will be longer than both A and B. It would be like this. Tell me, children. You need to put two things side by side and try to reconcile one with the other. Try to find the difference between the two things or the similarities between the two things. Vishnuvardhan? Children, tell me.
Wait, sir.
So when the angle is 180, vector difference becomes maximum. The magnitude of vector difference becomes maximum.
Done, sir.
Right. Now,
Wait, sir.
yeah. Yes, Moshagya, I'm waiting.
Done, sir.
Just right. Now,
Done, sir.
yeah, another case, case 3. When the angle is 90 degrees, what will you get? When the angle is 90 degrees, 2AB cos 90, that becomes 0
A is mod A square plus mod B square under.
under root. So is it looking like sum only? isn't it? Look, case 3. When theta is 90 degrees, that means two vectors are at 90 degrees to each other. So if you go by the formula alone, mod of A minus B would be under root mod A square plus mod B square minus 2 mod A mod B cos 90. Cos 90 being 0, you have the values in the table. Those who forgot it can look into that. Mod B square. Now the same thing you show in a geometrical way. It is like this. This is vector A. This vector B. You reverse it. Remember all this reversal. Everything I'll do. Everything I'll use in physics problems later. This is my A minus B. You know very well this was A plus B. Though the magnitude of both of them is, look, mod of A minus B equals mod of A plus B here, but this vector is different from this vector. Both the magnitudes are simply mod A square plus mod B square only. Hello?
Yeah.
Now, since now the main what you call the basic engine is completed, the main core of the ideas. Okay. Now tell me, you have any questions, because some with it, difference with it. Any questions? Vasist? Is everything looking justified, or is there any kind of a hazy kind of a feeling? We can check few more cases as compared to some. Before I continue, you may ask few questions, children. Because I was just doing it. Though slowly I was doing, I was not asking you questions there while doing it, because I thought, let me finish off that so that you got enough matter there to ask for. Tell me. Look, let me do I'll add a case 4 also for your information. Case 4, that way you can remember easily. I've got mod A equals X, mod B equals X, and theta equals 120. You know what was mod of A plus B?
Sir, X.
Yes.
Yes, sir.
Mod of A plus B is X. But what is mod of A minus B? Both algebra and geometry, both I want, because I give importance to geometrical visualization at 11th and 12th level, because that's the most of the times missing, and later people will be in trouble later in the higher studies. So come on, take it as a question for you and tell me. Either you can use geometry or you can use algebra. Hello, Vishnuvardhan, Vasist.
Sir, is it x root 3?
Who is it? Guru Charan? Huh?
Yes, sir.
That's correct, child. So how did you get it, Guru Charan?
Sir, I use the cosine rule.
Right, let us use it. Mod a square means x square. Mod b square means x square. Minus will be there in the formula, in the algebra. 2 into x into cos 120. Isn't it so? Hello. Cancels. Minus becomes plus. It will be 3x square under root, which is root 3x. Geometrically, look at this. There are two forces. There are two vectors. The angle is 120. This is vector A, this is vector B, but magnitude of this is x, magnitude of this is x. What is the angle now? 120. So if I find the sum, it will be like this from the middle of it, right? Huh? Hello, but I don't want the sum. I would like to reverse B. So if this was 120 children, how much is this? 60. So if I add x and x with 60, what will I get? If I add x square plus 2x square cos 60. So this will be my difference, root 3x. This is my sum. So both this geometrical and algebraical way of doing things should be really understood. Tell me. Hello.
Understood, sir.
Similarly, if I have theta is equal 120, one more case, theta equals 60, you put and tell me on your own now.
It will be x, sir.
X in the case of
A minus b. Mod A minus b.
and mod A plus B
Will be root 3x.
root 3x. That's correct. Hello, children. I want people to write it there and check it, not just tell the answer because somebody told. Others, I want you to write and find out for yourself. So did you write that? Hello, children. So I want you to say something. With theta equals 60, what are you getting? Mod of A minus B is what? X. Whereas mod of A plus B is root 3x. I want you to do this kind of a reversing and see the vector. Where is a minus b? Where is a plus b? All the time. So the first level of logical what you call adequacy will be maintained later. Hello.
Yes. Done.
Did you draw the picture and show it? It's like this. So physical children, later I'll show you why am I insisting upon all this. This is vector A, vector B. This angle is 60. So geometrically speaking, what should I do? I'll reverse this. Reverse what? B. So the angle becomes 120. So what will be the case? This will be my x. This is mod of a minus b. What was mod of a plus b? It was like that. So two vectors are different altogether. Hello.
Sir, once can you show the diagram for case 3, sir? Like since it is root over a square plus b square, and for addition also same.
If you're using algebra formula, for minus a minus b, you get a minus sign, minus 2ab cos theta. For plus a plus b, you get a plus 2ab cos theta. So what is that you asked? I did not follow.
Sir, no, sir, for 90 degrees also, when theta is 90 degrees, we get like when we subtract the vectors, we get root over a square plus b square, no, sir.
Yeah.
Even that's the same for addition of vectors, no, sir.
Yeah.
Once
Only that case. But I showed you already the difference is this one. This is a minus b, that is a plus b. So what is that you wanted in that? The formula gives, no? Whether plus 2ab cos 90 or minus 2ab cos 90 should be 0 only, right?
Yes, sir.
So, but
Sir, then
it,
tan alpha will be.
yes, tan alpha will be here positive, here it will be negative.
Okay, sir.
No?
Yes, sir.
It will be tan alpha will be this minus b by a.
Yes, sir.
This mod by a. Okay.
Okay, sir.
And others, please.
Yes, sir.
Any question?
No, sir.
No. Sure. Okay, then for today you can stop because the topic is over. Tomorrow, of course, the physical application of the difference of two vectors I'll be discussing. Like we talked about, what were the physical applications of some 3 examples I have provided to you. 1, tell me, 1, refer back to the notes and tell me. It's there already, we talked about it. Huh? What are you following? You're following, I think, some
Net force, resultant force.
net force on a body. And second, net force or resultant force, both mean same. Second,
Linear.
some of the momenta. Third,
velocity.
Third is resultant velocity, or the velocity of a swimmer from the shore, for example. Even if you tell that way, I have no problem. So similar to that, we've got specific examples here for the difference of vectors. Because mathematically speaking, reversing and adding is subtraction. When there are two physical quantities given, you simply don't reverse and add. That won't give you anything called physical meaning there. So all the vectors do not follow this, do not agree to be added or do not agree to be subtracted. So that's completely physics area where we need to talk about that. Okay. All right. I'll be closing it for now. Tomorrow we shall meet again.
Sir?
Yes.
Tomorrow tips through whose Zoom ID should we join, sir?
The same thing. But see that your parents come. Huh?
Yes, sir.
After 7:30, that is.
Yes, sir.
Okay.
Thank you, sir.
Thank you, children.